In this video, we'll learn about the possible outcomes for any linear system. As I told you before, for any linear system, we have two possible outcomes, which is consistent and inconsistent. For consistent, we can further categorize it into either one solutions or infinite solutions, whereas for inconsistent, we only have one no solutions. And what does it mean by the consistent and inconsistent for any linear system? So just imagine you have a system of linear equations, let's say x plus y equals to 1 and 2x minus y equals to 3. Let's assume this is your linear system. For consistent with one solutions, the values of x and y that you found from your solutions, when you substitute this value into both equations, let's say equation 1 and equation 2, you'll get back the values of 1 and 3 exactly the same as on the right hand side. Whereas for inconsistent, no solutions, the values that you found for the x and y, when you substitute into the first equation, maybe you will get the values of 1. But when you substitute into the second equation, you wouldn't get the values of 3. So the values that you found is inconsistent, and there's no solution for this linear system. Whereas for infinite solutions, normally the values that you found, let's say maybe x will be depending on y, or maybe the y will be depending on x, which means that one of the values or one of the unknowns is depending on the other one. So you can simply assume any values, let's say for x equals to 1, 2, and 3, whereas for the y, you will get the corresponding values depending on the values of x. So this is the case for infinite solutions. And I have told you that you can use the degree of freedom, where you have the number of unknowns and number of equations, which must be independent. So using these values, or the difference between the number of unknowns and the number of equations, you can check whether the system has one solution, infinite solutions, or no solution. But bear in mind, this is just an estimation of solutions. It does not represent 100% true whether the system of linear equation will have one infinite or no solution. So this is just an estimation. Moving on, let's look at the example of no solutions. Let's say this is your system of linear equation, and you either can solve it manually or using the row operations. And since row operations will be the main techniques that you'll be using frequently in this linear algebra course, I'll show the example of row operations. Let's put the system of linear equation into this augmented matrix form. 1 corresponding to 1, the x here, and 3 is the second equation here. So once you reduce it into the simplest form, let's say I want to get rid of the second row. So I'm going to multiply the first row with -3 and add it to the second row, and you'll get 0, 0, and -6. The meaning of this the second row is you have 0x plus 0y equals to -6. So this shouldn't happen because it is illogical. You can't have a 0 multiplied with x plus 0 multiplied with y and you get a values equals to -6. So this is actually an indication of no solutions. And if we look at the degree of freedom, let's use degree of freedom to check whether the estimation is correct or not. So we have the number of unknowns here is 2, which is the x and y, and number of equations is 2 as well. And you get the value of 0, which supposedly tells you that you can solve the system of linear equations. But this is not the case after you have carried out the row operations. So the tips for the no solution is when you have illogical equations in your final solution, something like 0x plus 0y is not equals to 0, which means that there is some other values here. And this is one of the example of a 3x3 augmented matrix form. You have 1, 1, 0, 1, 0, 1, 2, 1, and 0, 0, A, B. So what would be the value of A and the value of B such that this system of linear equation has no solution? So you may pause the video and try to guess or maybe refer to your textbook before we move on to the next one. Now let's look at the case for one solutions, and this is our system of linear equation. You put it into the augmented matrix form, and I want to get rid of the second row. So I multiply the first row with -2 and add it to the second row to get rid of the 2 here. Get rid of these 2. So you get 0 and 3, and you further simplify it into the reduced row echelon form, where you have the leading 1 at each row. So this indicates that y equals to 4/3, and the first row indicates that actually is x minus y equals to 1. And then you rearrange it, you should get x equals to 7/3. So you get exactly one value for each unknown. And when you substitute the value of x and y into either the first equation or the second equation, you will get the values exactly the same on the right hand side. So let's check with the degree of freedom here. The number of unknowns is 2, x, y, and the number of equations is 2 as well. So you get 0. And again, as I said, the degree of freedom is just for an estimation. So 0, when you get a 0, which means that probably this system of linear equations has a solution. So you should proceed with the row operation to check whether your degree of freedom estimation is correct or not. And the tip for any matrix, the tip for a system of linear equations with one solution is the matrix with a leading 1 along the diagonal, which means that you will have 1, 1, 1, 1 here along the diagonal, corresponding to, let's say maybe this is w, z, y, x. So you get a w for any number, and here is z plus w equals to another number. So you can substitute the value of w to get the value of z, and you do the same for the y and x. So for this system to have one solutions, so for this system to have one solution, the number of unknowns must be equals to the number of leading 1, which means that you have 4 unknowns, right? So here should have 4 rows started with 1. Now let's move on to the next one, is infinitely many solutions. So this is our system of linear equations, and you put it into the augmented form, and I want to get rid of the second row. So I multiply the first row with -4 plus and then added it to the second row. So you get a 0, 0 here. And this case indicates that you have 4x minus 2y equals to 1. So x, it can be expressed in the form of y. And y here, the parameters or the unknown on the right hand side will be known as free variable, and normally we elaborate as t, and which means that if y equals to t and x is actually depending on the value of t. So let's say t equals to 0, 1, and 2. So the corresponding value of x will be something, something, and something, which I have told you in the first moment, where x values depend on the t. So t here is the independent parameter, whereas the x is the dependent one. And let's check with the degree of freedom here. So the unknowns is 2 and the equation is 2, and supposedly you should get a 0, right? But if you look carefully for these two equations, you'll realize that the second equation, R2, is actually a multiplication of 4. It's 4 multiplied with R1, which means that the second equation is not independent, which means that the second equation is actually a repetition of the first equation, and supposedly the number of equations here should be 1, and you have a 1 here. So for the tips to recognize whether the system have infinitely many solutions, so normally you have a whole row equals to 0, something like this, whole row equals to 0. and the number of equations must be lesser than the number of unknowns, such that the extra unknowns can be the free variable. So let's say you have this system of linear equations which has been reduced into this simplest form. This is actually a row echelon form in the augmented matrix form. So based on this matrix, can you tell me what is the number of unknowns here and what is the number for equations, and let's use the estimation for degree of freedom to predict your outcome, and how many free variable and which one. So let's say this first column corresponding to x, y, z, v, w. So you tell me how many unknowns here, how many equations here, and what would be the degree of freedom. And if it has infinitely many solutions, which one will be the free